Greetings, children, and welcome. Today, we're beginning Unit 8. There's a quote at the beginning from Euripides. It says, "Whoso neglects learning in his youth loses the past and is dead for the future." So, what we can see from that quote is that people in the past have already learned a great deal. And because of that, it's conveyed to you in a simpler form. So you can learn from the past, all the lessons that have already been learned, and then that sets you up to learn even more in the future. There's another quote from a famous mathematician, and he said, "If I've been able to learn and perform great deeds, it's because I stood on the shoulders of giants," saying that the people before him were the ones that really taught him what he needed to know in order to achieve even greater learning. So keep that in mind as we study geometry. So you can see here, the word geometry actually means to measure the earth. So geometry, we're talking about measuring things. You've probably learned some basic geometry in the past. We're going to keep it pretty basic in this first section as well. The type of geometry that we're learning is Euclidean geometry. There's also several types of non-Euclidean geometry. Non-Euclidean geometry is applied to different parts of nature and different parts of our universe. As far as we're concerned, we can use Euclidean, which is also called planar geometry, to represent things because we're on such a small scale that things are flat. Of course, the Earth itself is a sphere. There's also a type of geometry called Spherical Geometry or Riemannian Geometry. And then there's Hyperbolic Geometry or Lobachevskian Geometry. And that's theorized, at least. Einstein theorized that the universe itself is shaped like a hyperboloid, which is a three-dimensional hyperbola. So those geometries actually work. They work in a different way than Euclidean geometry works. The concepts that we would learn here would have to be redefined for Riemannian or Lobachevskian geometry. But let's take a look at some basic concepts here and their symbols. So the first one that we're going to talk about is a point. Now what you have to remember is when we draw a point, it's just like this, a little dot. However, a point actually has no dimensions. It doesn't actually have any width, any height, any depth, no dimensions. When we draw it, we have to use something to represent it. So we just draw a dot. When you're referring to a point, you use a capital letter, like A, or you might have another point over here, B. And that's how we can refer to points, is by a letter that represents them. And then we have a line. Lines in Euclidean geometry are straight. So we have a line. Every line has at least 2 points on it. Like this line has points A and B. There's other points on it as well. In fact, it's made up of points. And it extends infinitely. That's why we've had put these little arrows on here, meaning it goes on forever in both directions. Okay? So a line is just one-dimensional. And then we have a line segment. A line segment is just a portion of a line, as the name implies, a segment or just part of a line. So here you can see line segment AB. When we're referring to a line segment, we use the letters where it starts and stops, and then we just draw that symbol above it, just a little symbol. It's just a little straight line. If we were referring to the entire line that we had drawn before, we would draw AB and arrows on the ends. Now, for a line, you can switch the order. For a line segment, you can as well. You could say it's line segment AB or line segment BA. Line AB or line BA. Both of those would be acceptable. The next concept we're going to look at, though, is a ray. So for a ray, we have a place where it starts, and then it goes on forever in a single direction. So the place where it starts is called its endpoint because it ends there, and then it goes forever in another direction. So as you can see, we have a ray. It starts at a specific spot, A, and it goes towards this other point and through it. That's point B. So whenever we draw the symbol, it always goes from left to right, and it points from left to right, no matter if we're starting, or no matter which direction it's actually facing. You write the starting point first, A, and then the next point, B. So let's look at a different ray. Let's say that we had one that started here and went in that direction, and this was D, and this was C. So we would still draw the symbol like this, and then where it starts, D, and which way it goes, towards C. We can also look at an entire line. Let's say we had H, I, J. Okay, we could talk about ray HI. So it would start at H and go towards I. We would draw it like this. That would be this shape, starting at H and going towards I. It also goes towards J. So we could also name it HJ. Okay? And then we could look at a different ray. Let's say we had one that started at J and goes towards H. We still draw the symbol in this direction. So if we're looking at this, we would say ray JH. You could also name it ray JI because it also goes through point I. But the starting point of a ray is important when you're naming it. Okay, that's our next concept, is ray. The next one is an angle. An angle is when you have two rays that share the same endpoint, and we call that endpoint a vertex. So this point here that's common between the two rays is called a vertex. When you're naming an angle, you can name it in several ways. So let's look at what those are. Let's say we had A, B, and C as the points. So one way to name this angle is by the vertex. You could just say angle A. And as long as there aren't any other angles at A, then it's clear that this is the only angle. Then we could just name it angle A. You can also name it angle BAC. The order that it goes from one ray to the vertex to the other ray. So BAC. And then there's a third way, CAB. So there's three different ways to name every angle. Now sometimes we can't use just angle A, and that's when there's another angle. So let's say there's another ray here, and it's D. So you couldn't name this angle A because we wouldn't know, are you talking about this angle? Are you talking about this other angle? Or are you talking about this big angle here? So we couldn't use angle A for those because it's what we call ambiguous. Ambiguous means that there's more than one possible interpretation or meaning. So an angle has a vertex, and then the two rays we call sides. Okay? Now there's some other things in geometry we're going to talk about today. Intersecting lines. And there's an important concept here. It says intersecting lines are lines that have one point in common. So we're talking about two lines that just intersect in a single point. Now we said when we name a line we could name it by the points that are on it. You can also name it with a lowercase letter if it's referred to as that. So this could be like line M, and this could be line N. So if there's points on it that are named, you can name it like that. If there's not, if there's just letters that refer to each line, they would be lowercase, and we could refer to it as those lowercase letters. But let's say there are points here, A, B, C, D, And then here where they cross or intersect is point E. Another word for intersecting lines is concurrent lines. A lot of books use that term. Your book does not, however. Concurrent just means that they intersect in a single point. That point is called the point of concurrency, or their point of intersection. So you can see here, we can name these line AC. So this would be line AC. This would be line BD. And we can say that they intersect. Sorry, that's supposed to be BD. And they intersect at point E. So there's a sentence here that says two lines can intersect in only one point. So unless they're the same line, if we're talking about two distinct lines, two different lines, then they can only intersect in a single point. In this case, it's point E. The next geometric term we're looking at is a plane. Now, if we're looking at this board here, this board would be a plane. Okay, because it's a flat surface. A plane is two-dimensional. So this wall, the whole wall is a plane. The floor would be a different plane. The ceiling a different plane. This other wall on this side would be a plane. The wall on that side is a plane. So when we're talking about a plane, we're talking about a flat surface. Usually when we're trying to draw a plane, we'll draw something that looks like a parallelogram. We'll have something like this. And planes are usually referred to by a lowercase letter, just like, so this could be plane P. Okay, so just like a line, you can refer to a plane with a lowercase letter. It doesn't always have to be drawn as a parallelogram. It's just a lot of times when we're referring to a plane, we'll use that shape. And then the last term that we're going to talk about today for geometry is parallel lines. Now, parallel, and a lot of people get this wrong, but parallel is spelled P-A-R-A-L-L-E-L. So keep that in mind. Parallel, P-A-R-A-L-L-E-L. Parallel lines are lines that are in the same plane that never intersect. So that first part's important too, because you probably learned before that parallel lines don't intersect. Well, they also have to be in the same plane. If they're not in the same plane and they don't intersect, that's something different called skew lines. So if they're in 3 dimensions, one's going this way and then one's coming out over here, out of the board, so in like a 3rd dimension, then those would be considered skew instead of parallel. They also don't intersect, so it's not enough to just say lines that don't intersect are parallel. No. Lines that don't intersect and are in the same plane are parallel lines. So parallel lines, an example would be something like this. Remember, they go on forever, but they don't intersect. There's a symbol for parallel, so let's say this is AB, and this is CD. So to write it, we would say line AB is parallel to line CD. So the symbol for parallel is 2 vertical bars. They're bigger than the letter. You can see here's the letters, capital letters A and B. And it's just 2 vertical bars that look like that. So that's a symbol for parallel. So you would read this, it's a whole sentence. Line AB is parallel to line CD. So those are the concepts that we're talking about today for geometry. We have some other concepts. If you look forward, you can see there's geometric planes and shapes, types of curves. If you look on, there's things about area and volume. And then there's special types of triangles, special types of angles, facts about triangles, and then we get into 3-dimensional shapes like cones and spheres and pyramids and cylinders. So there's all kinds of stuff we can learn about geometry. So keep your mind open. We'll see you next time. Have a great day.